You are absolutely not going to believe this. So we are on the home stretch here and getting our final inspections. I was waiting for inspections on Wednesday, expecting the HVAC and the plumber. HVAC actually went pretty well and we passed. The plumbing inspector was here, the contractor was here to meet him, and I got a phone call from the contractor and he was like, hey, the water's not getting hot. And I was like, oh, probably, we turned off the water heater because no one's down here in this unit right now. So I come down to double check and make sure that the breaker's on and the water heater's on. And I walk in and all of the faucets are on. The inspector had turned on every faucet, the hot water, full blast, running the hot water to test it. So I come in here, the bathroom and all the faucets are on, and the water heater shows an error, E5, which we looked it up, and it means that there is too much water flowing through the heater for it to heat it properly. So it's just not getting hot. It's a little warm, but it's not able to actually get it hot enough. And if I turn on a few more, it'll stop being warm at all. It's trying, it's a little bit warm, but check this out. It's only getting it up to 75 degrees, which is absolutely ridiculous. So you're probably thinking, well, that's silly. Nobody would ever run both bathroom sinks, both bathroom showers, and the sink kitchen faucet all at the same time, all on full hot. Well, obviously, yes, no one's gonna do that, but he did point out the actual safety issue with this, which now that I think about it, makes a lot of sense. If you're here and you're getting lukewarm water out of the faucet, someone at some point is going to go into the bathroom and turn up the water heater. So someone's going to be getting lukewarm water out of the kitchen and they're going to come here and turn up the water heater as hot as it goes, which is 140, which is extremely hot. Now we've got water coming out of the kitchen sink at 125, which is too hot. So I went and dug up the specs on the water heater, and it turns out that these instant on-demand water heaters are able to heat some volume of water a certain number of degrees based on the flow of the water, which makes sense. So if you've got like 1 gallon a minute flowing through, then this one with the 3 heating elements in it can raise the temperature by X amount. And if you double the volume of water, then the amount it can raise the temperature goes down. And it's actually a pretty steep curve, how much it struggles with trying to heat a faster volume of water. So if these are all like 1 or 1.5 gallon a minute fixtures, and we've got 2 showers, 2 bathroom faucets, and a kitchen sink, that's at least probably 6 or 7 gallons a minute. And the problem is that it's based on raising the temperature of the water, right? So our water's coming in from the city, actually pretty cold in Portland, and it's about like 45. So in order to get it to, if you are trying to target 105, that's a 60-degree temperature rise. And the water heater just can't do it. And it's not about trying to find a more efficient water heater, because this is about as efficient as you can get. Basically, all of the power that it's drawing from the electricity is being converted into heat. Very little waste. So it's just up against physics at that point. So you can, to some degree, add more heating elements. We already have 3 in here. There's 3 heating elements in here, and that means there are 3 separate 240 volt, 40 amp wires going into this. I have a picture of it opened up actually, because I was curious when they were wiring it up, and I grabbed a picture inside. It's kind of crazy. It's just power going into the heating elements. So that's 120 amps that this can draw at its peak. And we only have 200 amps of service in this unit. That's a 200 amp panel. So if there is a one model up from this, there's one size up that has 4 heaters in it, and that would draw 160 amps at its peak, which is now getting uncomfortably close to the 200 limit. So if you have that and the heaters on, for example, you might actually get close to the 200 amps. And that's only going to give us a 25% increase in what it can do. So again, it's just not really going to cut it. I think the short answer is that these instant on-demand water heaters are really made for warmer climates. Like if your city water is coming in at 75, then you only need to go up 40 degrees instead of 60 or 70 degrees to get it to a hot water temperature. So the electric ones are just really not usable in the Pacific Northwest here. So how are we going to solve this? That is the real question. Well, I think the answer is we just have to get a different kind of water heater. We're already using too much power as is with these. We're basically at as far as we can go. I'm not going to add gas, and not to mention the logistics of even doing that at this point would be ridiculous. So really the only answer is to use a different kind of water heater and just go back to a tank. The inspector was only in this unit, but we're going to have the same problem in the other units. There's the same number of fixtures in units A and B above, and then our unit actually has more because we have a second kitchen sink and a bathtub in addition to the 2 showers. And actually a shower head on the roof, so there is no way it's going to cut it for that either. So basically it means we're switching to tanks. So I did a lot of research and looked around here to figure out if it's going to fit. Let's first take a look in Unit A. So this is the bathroom in Unit A, which has kind of by accident made this perfect spot for a water heater. And the hot water pipes are there, and the drain for the water heater. So basically, this one should be pretty straightforward. We're only going to need one of the circuits that's going into the hot water right now out of the 3. And we will take the cold water, take the hot water, use this drain. This drain goes actually under the kitchen sink because I don't know why, but they forgot to add a drain that's properly plumbed in. That's a different story. Anyway, it's there, it works. It'll hold a tank water heater just fine, and there's plenty of room for it, as you can see. And it won't really be the end of the world to have a water heater tank next to the toilet there in that little corner. I was planning on building shelves there, so we lose the shelving, but at least it'll fit. The water heater for Unit B is in this bedroom. So this is the bedroom that has the connected bathroom. It's next to the kitchen here. So actually all the plumbing is pretty close to this spot, which is convenient. And we've got the same situation here where we've got the instant water heater, and it's just not going to cut it. So I took some measurements, and I actually already bought this pan, and it just showed up yesterday, and it just barely fits exactly there. That's a 22-inch pan. So we can get an 18-inch water heater. I think it might be a little bit of a squeeze for a 20-inch. So I found an 18-inch water heater, which is 40 gallons, and it's going to sit in the closet there. Again, it'll be a pretty easy swap because we've already got the pipes and the power. They will need to cut a new drain hole because that one is too high up, but this is an exterior wall, so that's actually very easy. They can just poke a hole for the drain pan down in the floor there and a hole a little bit higher up for the drain from the tank. We lose some closet space, but it's actually not that big of a deal either because there's 2 closets in this bedroom. So that one will still be a full usable closet. And here I'm gonna probably have them just put like a panel in the middle so that this door is effectively the water heater side, and the other side is the closet side. It does mean that the shelving I bought for it is going to not be usable, or I'll have to be creative about how to shove it in only half of the closet. So not the end of the world. This one's pretty straightforward. Really just 2 little holes we need to cut in the side of the building, and it'll work fine. Our unit, however, is a bit of a problem child. So the water heater right now is inside of Lily's office closet, which is arguably not the best place for it, but it was like one of the only places that even made sense in the first place. And in retrospect, thank goodness we didn't even try to put it into the bathroom because we had to reconfigure the bathroom quite a lot compared to what the original plan was for a number of reasons. Anyway, water heater's in the closet. Lily's closet has a sliding pocket door, and in the back corner, there's shelving, which is useful for storage. And that means that if we replaced the Tankless with a tank, it would effectively block the entire closet and the closet would be unusable. You wouldn't really even be able to get in to use the shelving, so that's not a good plan. So that takes me down here where I am in the second bedroom of Unit A on the basement floor. This was actually the electrician's idea, and I am really glad he thought of it. So above me is Lily's office, and the office closet is about almost exactly at this wall. I think it's like a foot away from this wall. That means our hot water pipe comes in or feeds our unit from right about here. And what's on that wall? That's the exterior wall where we have our outdoor closets, one of which is filled with networking gear and our house battery. and the dumbwaiter controller. The other one has nothing in it, and my plan was to use it for storage, like yard tools and just storage for dirty stuff. However, that is now looking like the best spot to put a water heater. So basically we can come into this unit, cut open the ceiling, run the 2 pipes and the power out to that closet and turn the left side of that closet into a water heater room. It's a little weird having it be kind of like an exterior closet with the water heater in it, but it will work. There's no reason it's not allowed. That is already part of our unit because the power that goes into that room for the light is already fed off of our panel, not the house box. So we'll just we'll cut open a big trench and then extend the 3 40-amp circuits and the hot and the cold water through the trench in the ceiling into the closet and put it all over there. Funny enough, we have actually done this before. Not that long ago, just a couple months ago, we had kind of the same problem where the exterior closet is over there and the future location of the shed for bike parking is right beyond that wall. And we needed to extend the sprinkler system, the fire sprinkler system, into that shed. Well, there happens to be a sprinkler head right here. So what we actually did was we had them come in here and they cut open the ceiling from about a foot before that sprinkler head to the wall. They were able to extend the pipe from that sprinkler head through into the closet outside. And then we can run a pipe from that closet down to the shed, future shed. So we've already done this. We've already had them come in, cut open the drywall, the 2 layers of drywall, gut it, get insulation out, put it all back together again, come back and do the drywall. So we're gonna have to do the same thing all over again for right here. So our new sprinkler pipe comes in there, and then that vertical one goes and runs underground over here into where there will eventually be a wall. So that's going to eventually become the exterior wall for the shed, and we'll have the sprinkler plumbed straight into it. So this left one, which is totally empty, this will become the water heater room. And you can see that the bedroom ceiling is at the height of that pipe sticking out of the wall there. So basically we'll have the same thing over on this side, 2 pipes and some electric coming out of the wall at that height. And then this is already outside, so the drain should be easy to deal with, to probably run a drain pipe through the room there and go out the back. I am so ready to be done with this. And so I actually yesterday ordered 3 water heaters, and 1 arrived yesterday, 2 arrived about a couple hours ago. I just want this to be done. So they're going to come first thing next week, start ripping open the ceiling, get everything ready for these to get installed, and then the plumbers are going to come here and do this all in one day and knock it out. So I did end up with 3 different models, and I mentioned that Unit B closet's pretty small, so I got an 18-inch 40-gallon for that unit. 40 gallons is on the small side for a water heater, but it should still be plenty for what will be needed. It also does have the first hour rating that is required, which is I think 60 gallons. So essentially during the hour, it'll be pulling in more water, heating it up, and it can keep that temperature for an hour. For this unit, for Unit A, I got a sort of normal size 50-gallon, and it was basically the biggest that would fit in that little area. And then for ours, I did something special, which since we are in the outdoor closet and this is the only thing that's going to be in that closet now, I basically went big because why not at this point? So I got an 80-gallon, and it's also a heat pump water heater. And the reason I got the heat pump is, 1, they're more efficient. They are noisy, so it doesn't make sense to do it in here because this one's in the bathroom and upstairs is in the bedroom. So you don't want a compressor in the bedroom, obviously. But ours will be on the outside closet, so it doesn't really matter if it makes noise. And the heat pump is more efficient, but it also is effectively an air conditioner. So in the closet that it's in, it will be cooling down the air, which is convenient because right next to that closet is a closet full of servers that like to generate heat. I actually already swapped out the water heater in the loft because it was 17 years old, which is approaching the end of life expectancy of water heaters anyway. And I really didn't want to be in an emergency situation where I had to get it swapped out in a day. So I proactively swapped it for a heat pump water heater. Also because that room also has servers in it. And wow, what a difference it makes. So the servers will heat that room up to typically like 90 even in the winter, and in the summer it was getting over 100 in there. And you know, I can run a fan and try to pull air out of the room, but if it's hot outside, it's not going to make that much of a difference at the end of the day. So now that there's a heat pump water heater in there, it is an air conditioner for the room. So the room has been staying between 50 to 70 now, even in the hot summer, because it just cools down the room, and then the servers make the heat that the water heater needs to turn into hot water. So it's kind of like a little free heat, right? Like the servers are on anyway, and instead of wasting that heat, let's take that heat, turn it into hot water, and that's a lot more efficient. So we'll be doing the same thing with our hot water heater for the exterior closet. Gonna have to cut some holes in the wall between the two rooms, but it's just a thin wall, so it's no big deal. So with any luck, the contractors and the crew is going to show up and actually start working on this next week. So we'll check back in a couple days and see how it's gone. So who's late this week? Well, randomly, actually, I think I'm going to call it the low voltage inspector. He was supposed to have been scheduled for the same day as the other two. I was trying to bundle them all into one day, and he just didn't show. And it turns out it got scheduled on the wrong Wednesday. So he'll come next Wednesday. We'll hopefully, I won't find anything wrong with low voltage. Cross your fingers. I'm hoping it's an easy one. What we didn't know we needed to know. Well, I'm going to call this one the water heater situation. I just kind of assumed that between the original plans, the contractor and the plumber who installed it, somebody would have pointed out that this wasn't going to work. But apparently no. Apparently I needed to do the math myself and figure out the max water flow for all the number of fixtures, the temperature our water comes in from the city, and look at the charts to figure out the max temperature rise for the gallons per minute when all the faucets are on myself. And nobody told me that. I don't know, everyone seems to be pointing fingers at each other, so I don't really understand how this is supposed to work normally. Also, I know other buildings have done instant hot water before, so is this inspector just being nitpicky and testing the impractical scenario of turning on all the hot water taps all at once? In any case, this plan of just replacing the water heaters is honestly probably the fastest and cheapest solution to this at this point. So I'll leave you with that, and remember, don't build a triplex.